Hello and welcome to yet another exciting webinar from GS Lab. My name is Kudal and I'm going to be the moderator for this webinar today. I see a lot of people joining in yet, so let's give them a minute to join in. In the meantime, you can download today's presentation into the handout section on the right hand side panel. If you have any questions during this webinar, make sure you type all those questions in the questions tab, and we'll try to make sure that we answer all these questions at the end of this webinar. Even if we are not able to answer these questions due to time constraints, we will make sure that we will send out a detailed question and answer sheet to all the attendees about the questions asked during the webinar. And don't forget to follow us on our social handles. We keep on posting a lot of interesting stuff on technology. I'm sure you will love to read that. Okay, I see a lot of them already joined in. So without any further delay, let's begin with our webinar. So the topic for today's webinar is demystifying data science, AI, and ML. Now at GS Lab, we have been implementing data science solutions for a lot of our customers. And the discussions that we had with our customers and a lot of prospects that we talk to every day generally are seen a lot of confused with the terminologies data science, AI, and ML. They usually use them interchangeably, and sometimes the implications and the need of one technology is not applicable to their problem. So what we thought was we should make sure that we help understand everybody what is the difference between data science, AI, and ML, and then we will deep dive into what data science is all about and how data science can be used in today's business scenarios. And for this webinar today, we have two speakers with us. We have Vineet Raina, who is the Chief Data Scientist and Architect at GS Lab, and Srinath, who is also Principal Architect at GS Lab. Both Vineet and Srinath have 15 years of experience, and they have been instrumental in setting up the data science wing at GS Lab. Vineet and Srinath have been delivering a data science solution for a lot of our customers, especially in the healthcare, manufacturing, and logistics and supply chain domain. Vineet has two US patents under his name, and he is a frequent speaker at a lot of academic and industry events. While Srinath is instrumental and is a consultant for a lot of businesses to help them understand what data science is and how data science can be applied to their scenario. So before moving on, we'll just run through the agenda once before I hand over the controls to Vineet. So the agenda today is in the first section we are going to cover what is data science, which will be covered by Vineet. And here Vineet will help us understand the difference between AI, ML, data science, and DL, and the complete data science process associated with it. And Srinath will help us understand the business implication of data science and how data science can be a game changer for a lot of businesses in today's world. Now, Vineet had requested us to run a quick poll just to understand and get a feel of what people understand of these three technologies. So before moving or handing over the controls to Vineet, I would like everybody to take up a quick poll. The question for this poll is, which of the following will you associate email spam filters with? And I'll just release the poll for everybody. You will have 30 seconds to answer to this poll, and after that, we'll hand over the controls to Vineet. Okay. So here are the results. And Vineet, you can take it over from here now. Here are the results for the poll. So 17% of the audience says artificial intelligence is the answer. 63% of them say machine learning is the answer, and 21% say data science is the answer. Over to you, Vinit.
So thanks, Kunal, and welcome everyone to this webinar where we'll try to demystify these terms AI, ML, data science, deep learning, and we'll understand what their relationships are, how they are different. And for the answer to the poll, I hope that by the time we are towards the end of this webinar, you will have automatically know what is the answer for this poll. So let's get started with these terms. We'll begin with AI, which is the outermost field. And before understanding what AI is, let's first try to look at human intelligence. So if you see how human intelligence works is your brain gets a lot of inputs in the form of vision, hearing, touch, and based on those, it processes those and takes effective decisions. So for example, we all drive vehicles. So the manual gearbox, what our brain is doing while using that is it understands the speed, RPM, incline of the road, and based on that, then it decides what the right gear will be. Similarly, when we look at mails, our brain looks at the patterns in the emails and it can understand which mails are spam. Also, while playing chess, our brain looks at the positions of the different pieces and then decides the best move. So these are some examples where human intelligence takes effective decisions based on inputs. Now, AI is nothing but the simulation of this human intelligence by computers or machines. So let's look at this in more detail. So again, you see a similar picture as the previous one. Here, the machine gets the inputs in the form of sensory inputs such as levels or visual inputs like video or images. And based on those, the AI system takes effective decisions. So again, you see three similar examples as the previous slide. Now here, automatic gearbox is an AI system which will detect the speed, incline, RPM from the sensors, and based on those, automatically shift to the most appropriate gear. Similarly, AI-based spam filter will look at the contents of the email and block the spam mails. And AI-based chess engines will look at the board positions and play chess. So you can see AI systems do something similar to what our brain does by taking effective decisions based on inputs. Now, AI is a broad space which covers it is based on two approaches. One is the rule-based approach. This is the more traditional approach where some developer, while implementing the AI system, will implement a bunch of rules to address this scenarios. So for example, if you are looking at chess engine, some developer will implement the rules to play chess. Then the other kind of approach for implementing AI systems is the data science based approach. This uses data science to implement AI. So to understand these in more detail, let's look at the example of chess in more detail. So this slide shows the AI system based on the rule-based approach. The picture that you see here on the left side is a grandmaster playing chess, and on the right side is an AI system which is based on the rule-based approach and is playing chess. For the rule-based approach, what the system does is some developer, as I said, has implemented rules based on factors like king safety, pawn structure, effective moves for different situations. So based on all those rules, the program plays chess. So this is the traditional rule-based approach. Now let's look at the other approach for data science for AI, which is the data science approach. Here you can see almost the same image. Again, an AI-based system on the right is playing a grandmaster on the left. But this data science approach, instead of using some rules, it plays the moves based on winning moves in the past games. So a crude way could be that when it encounters a particular board position, it compares that board positions of the different pieces with the past set of games that it has. And if it finds that there are n number of games that match this particular game that is in progress, and let's say it finds that 9 out of 10 times when a particular user played a particular move, 9 out of 10 times that player won the game. So it then plays that particular move in this game as well. So what here the AI system is doing is it is using the power of the past games and playing the moves accordingly. So this is what the data science approach for AI is. Now let's again compare the two approaches based on the spam filter example side by side. Now if you have a spam filter AI system based on the rule-based approach, some developer will need to implement the rules for detecting spam. So for example, he could implement the rules like if the mail begins with congratulations dear user, then it is a spam. If it has been received from some particular email address, then it is a spam, and so on. There will be a long list of rules that he'll need to implement. And also whenever there is a new kind of spam, the developer will have to update the code to catch the new kind of spam emails. As against this, the data science approach offers more benefits. So as the basic approach, what it will do to find out whether a mail is spam is, it will compare the mail with the previous spam and non-spam mails to put it in a crude way. Internally, obviously, it will have a lot of mathematical details and use a lot of mathematical theorems. But if we want to say in a crude way what it does, we would say that it will just compare the mail with previous spam and non-spam mails. And if the mail matches previous spam mails, then it marks this particular mail as spam. Now, in this approach, the benefit is you don't need to change the code every time there is a new kind of spam mail. So, for example, let's say there is a new mail that has been received and your AI system fails to mark that as spam. So, now you as a user mark that mail as spam, that spam mail goes into the database of mails, and the AI system, next time it receives a similar mail, it compares the mail with the previous mails, and it finds that the new mail matches the previous one, which was spam. So it marks the new mail as spam. So you see automatically how the AI system automatically learns without you having to change the code every time. And now talking about the power of the data science approach out of the two approaches, the recent developments have proven the power of data science approach, where we have seen data science-based AI systems defeating world champions in their games. So for example, the data science-based AI system, AI engine AlphaGo defeated the world champion of the game of Go named Lee Sedol. Similarly, data science-based chess engines defeated the non-data science-based chess engines in the game of chess. And now we are hearing about Leela Chess, which is an open source AI-based data science-based chess engine that looks promising. So we till now saw what AI is, what are the two approaches of AI, the rule-based approach and the data science-based approach. Now let's zoom in a little into what data science is. So data science is extracting actionable insights from messy data. Nowadays, we have a lot of data coming from IoT sensors, social media, and a lot of other channels. And inspecting all that structured, unstructured, messy data and extracting insights which can lead to some useful actions that eventually result in benefits, that we can say is data science. And a few of the examples are analyzing the past data to predict future sales, or analyzing past games to play new games with high chances of victory, which is what we saw just now in the last few slides. Then the last one, fixing hotel tariff based on the past data. So this can be a tricky one. If you have a hotel business and you want to decide the tariff, if you keep a very high tariff, you may not get any customers at all. If you fix the tariff at a very low level, then you may not make much profit. So here data science can come to your rescue and based on past data suggest to you what is the best tariff for the maximum profit. Now, what all does data science involve? What are the different steps? We saw what data science is, but what are the different steps in data science? So the first one is, of course, the data capturing step where we capture the data. The next step is the data preparation step where we prepare the data for the next stage of machine learning. The final step is machine learning, which learns from data and then produces output like predicting future outcomes, playing games, and controlling devices. Let's look at these in detail one by one. We'll start from the reverse, from the last step of machine learning, because that is at the heart of this entire data science process. The bottom half of the slide shows the details of that machine learning step. So you can see the machine learning step receives the prepared data from data preparation step and it produces the output. Now what it internally does is this machine learning step learns from the data and builds a model. Now what is a model? As the name suggests, a model is a simplified representation of any real object, like a model of a building is a simplified representation of the building. Similarly, here the machine learning step tries to understand the data and create a model, a simplified representation of the data and its relationships. Let's look at an example to understand this. Here again you see the same machine learning step with concrete examples of what could be prepared data, what could be the output, and what could be the model. So on the left side you can see what is going to the model is the data of employees where you have their experience and salary. Now when you give this data to the machine learning step, it analyzes this, finds patterns, and it can come up with a model which can be as simple as an equation in this example, salary equal to 2 into experience. So this equation is nothing but the model in this case. It is a simplified representation of the relationships in data. Now using this simplified representation, the model can predict salary for even new employees. For example, on the right hand side you see if you ask it to predict salary for a person with experience 2.5, it will say salary is 2 into experience. So it is 2 into 2.5, which is 5. So this is how it predicts the outcomes for unseen entities. Now this kind of a model is a special kind of machine learning model which has a simple equation between the target variable and the independent variables. This kind of a model is called a linear regression, but you can have a host of other possible machine learning models. Now let's look at the first step, which is the data capturing step. It is also one of the most important ones. The bottom half shows the importance of this example. What this slide tries to emphasize is the importance of capturing all the relevant variables and what happens if you do not do that. So here in this case, you can see in the prepared data, what is being passed is the temperature, humidity, and rainfall data for past few days or maybe years. And you can see a column wind speed which is partially transparent, which indicates that this was not captured by whoever was capturing the data. Now when you give this data to the machine learning step, it creates a model. It understands the pattern that whenever the temperature is around 22, humidity is around 75, the rainfall will be around 8. Now it tries to use this model to predict future rainfall. On the right hand side you can see somebody is trying to predict rainfall on a day when temperature is 22, humidity is 75. So it knows that the rainfall is expected to be 8. But will it be correct? If you see on the left hand side the days on which the data was collected, wind speed was 10, but this was never captured. So this pattern is valid only when wind speed is 10. So if while predicting on the right hand side, if the wind speed on that particular day is 20, your output will be totally incorrect. So what this means is that no matter which models you use, your predictions or insights will not be correct if you have not captured the relevant variables or relevant data. The next step after data capturing is the data preparation step. So once you have captured the data, before passing it to machine learning, it may be useful to prepare the data in ways so that the machine learning step is more effective. Let's again look at an example to understand this. The bottom half here shows the details of the data preparation step. What it is basically doing is it is converting the original data to a different form. So the original data you can see here is the sale data for, let's say, a company. It contains the sale for every second since epoch. Epoch is 1st Jan 1970 midnight. So you have the data, sale data for every second. Now you can see that your sale will not depend on how many seconds have passed since epoch. If you give this data directly to the machine learning step, it may not find any patterns. But you as domain expert or just by using simple logic, you will understand that your sale will depend on which month of the year it is, because in December when it is vacation, people tend to go for shopping, so sales are high. Similarly, during a week on Saturdays and Sundays, the sale is high because people go out for shopping. So your sale depends on the month, which day of the week it is, which hour of the day it is, which year, and so on. So that is why, as part of the data preparation step, you may want to convert epoch time to hour, day, month, and year, and then you give this to the machine learning step along with the sale. So now the machine learning step can find the pattern and see that sale is high in December and high on Saturdays and Sundays and so on. So this is also a very important step which, if missed, can result in the models not performing well. Now this slide will just briefly skip through this. This talks about how you train the models and evaluate whether they are performing well. Now we looked at machine learning. Now let's look at very briefly look at the different types of machine learning based on how the models learn. So the first kind is supervised machine learning. Here human supervision may be needed to specify the labels for the training data. So for example, the spam filter we saw, there for the past set of emails, some user needs to specify which all emails in the past were spam, which were non-spam. So so that the model can then predict for future mails whether they are spam or not. So since this requires supervision, this type of machine learning is called supervised machine learning. It can further be of type classification if you are trying to predict classes like spam, non-spam, or it can be regression if you're trying to predict numeric values like salary. The other type of machine learning is unsupervised, which does not require supervision. So for example, if your model is just trying to find out which all customers are similar, then that doesn't require specifying any labels. So that is unsupervised learning. The third kind is reinforcement learning, which is the kind of learning used by the chess engines, where they play games against themselves, and based on which move led to better positions or worse positions, the chess engine learns which is a good move and which is not. Now to clear the confusion over machine learning and deep learning. So machine learning, we looked at what machine learning is, where it fits in the overall data science process. Machine learning, there are a lot of models that are used in the machine learning category. The example that we saw where the model was just an equation, salary equal to 2 into experience. That kind of a model is, as we discussed, linear regression. But there are other kind of models possible. A second kind of model is the decision tree based model, which creates a decision tree out of the data and then walks down the decision tree to make predictions. Third kind could be random forest, which uses multiple trees and asks them to vote based on which it predicts the final class. There are a host of other models possible. These are just a few examples. And a subset of machine learning is the deep learning, which uses neural networks that run over clusters of multiple machines. And there are different types of neural networks: feed-forward neural networks, recurrent neural networks, and these are very good at accurately predicting outcomes. And this kind of approach, which uses these neural networks over clusters, is the deep learning. So deep learning is a subset of machine learning. Now, we already looked at the data science process. Why we have this slide again is to emphasize that there are a couple of other steps that are generally followed. So you must already be familiar with data capturing and data preparation step by now. After data preparation, generally there will be a data visualization step where graphs are used to understand the relationships between variables, and that helps us decide which kind of models should be created in the next step of machine learning. And after machine learning step, when you have the model, you may have an additional step where you deploy the model on an end system, like an app, where you use the model for predictions or getting insights. And the bottom step you see is the data engineering. This is like an umbrella step that goes on throughout the data science process, and it involves activities like efficient storage of data, etc., that are used throughout the data science process. Now, data science process has these steps. You can see them listed on this slide again. The data bottom, if you see the bottom left half, you can see the data layer. On top of that, the data preparation layer. So these are the different steps in the data science process which we saw. What this slide shows is that there are techniques available for each step. So for example, in front of the data layer, the data step, you have the techniques for data capture, In front of the machine learning step, you have the techniques for machine learning like linear regression, neural networks. So there are a number of techniques available for each step. And just as there are techniques, there are also a lot of tools and libraries available. So fortunately, you don't have to implement all the techniques yourself. Somebody out there has already implemented most of these techniques in the form of libraries and tools. So this slide shows for each step of the data science process, what are the different libraries and tools available. And this is not an exhaustive list, but these are some of the common ones that you will come across. For example, in front of the machine learning layer, you can see scikit-learn library, TensorFlow library, which implements techniques for machine learning step. And even though a lot of libraries are available, but it requires experts who understand the techniques and which all libraries are available, libraries and tools, and how to use them in the best ways, which ones are more appropriate for which situations, and so on. So just to quickly summarize what we saw about all these fields, we began with AI, which is the outermost field. It has broadly two approaches, the rule-based approach and the data science-based approach. The data science approach, we saw that it has different steps, data capturing, preparation, machine learning, and so on. So machine learning is one of the most important steps in the data science approach. And a subset of the machine learning approach is the deep learning, which uses neural networks over large clusters of machines. So hopefully this should help you understand what are these different fields, what do these terms mean, and how they are related to each other.
Thank you, Vinny, for such a brief description about what is data science and helping us understand the difference between data science, AI, and ML. So with this, we have come to almost 60% of our webinar, where we have covered the differences between all these technologies and what is the overall process. And moving ahead, I would like to pass on the controls to Srinath, who will help us understand the business implication, the business side of data science, and how it is currently used by a lot of organizations. And Srinath also had a similar request. He would like to understand what the audience currently understands of data science based on what they have learned, and where do they think that data science will be useful for them. So we have a small survey question for you guys. I just launched the survey for you guys. Okay, so we need your help in identifying where do you think data science will be most useful in your business. Okay, and you have 4 options in front of you. You'll have 30 seconds to answer these questions. Post that, with the results, we'll hand over the controls to Srinath. Okay, so here are the results. So what we see is 19% of the people say that data science will be used to generate insights from the current data. 8% of them say that it would be used to develop new products which are based on data science. 0% of them say that data science will be added to their existing products, and 72% of them say all of the above. So I think these are very interesting results, and I'm sure Srinath would like to, throw some more light on this. So over to you, Srinath.
Yeah, thanks, Kunal. Thanks, Vineet. So the poll results were quite interesting, and folks seem to believe that data science can solve all kinds of problems in general. So let's take a look at some examples of each of these and how data science impacts business in different ways. So let's start by looking at a generic business process at a high level. So typically a business has some vision, and then a strategy is set out in order to realize that vision. And when the strategy is being executed, as part of the execution, certain automated processes might come up in an industry, or a technology company or an industry might create new products which are oriented towards realizing the vision. And based on these products and processes, the company typically starts collecting data. It could be data based on the product usage about the customers, or it could be monitoring data based on various processes and devices and various kinds of data. Within the business, when such data is kind of become available or aggregated over some time, is when the data science team comes into picture. And the team of data science professionals execute the data science process, which Vineet just explained in some detail, using various techniques, tools, and libraries. And as part of the analysis of the data science team, we kind of have two kinds of benefits. One is either operational improvements to the processes, or adding new features or capabilities to existing products. We'll see some examples of these shortly. Also, another benefit could be that the data science team could provide insights into potentially newer business models or pricing decisions. One example of this is the hotel tariffs example, which Vineet gave. So going into some more concrete examples, the first kind of benefit of data science is integrating data science capabilities into an existing product. So assume that we have an energy monitoring solution or an IoT solution in my company, and we can add capabilities to predict energy usage and make some decisions based on that. The other kind of data science implication is for creating new products which are entirely based on data science capabilities. So these are products or platforms which would not have been possible without data science. Example of this is monitoring health conditions based on voice, for example, and we'll take a look at that shortly. The third kind is quite common, that industries have accumulated data over a long period, and traditionally analytics or reporting is done to monitor usage and generate reports, but data science can provide additional insights based on this data, and we'll have a look at some examples of that. So the first example is detecting health conditions using audio samples by the data science process. So this is a data science process that Vineet just explained, and I won't be going into details of the typical steps in each of these. But when we are talking about detecting health conditions like depression, Alzheimer's, or stress, sleepiness, cold from just audio samples, we can imagine that the data preparation step typically involves a lot of signal processing to extract numeric features from the voice spectra. And then machine learning models are created for different conditions, including the patient's history, medical history, and demographics, and all those aspects. And in this case, we can see that the entire product conception is based on the data science models. So we need to build an entire ecosystem or platform around these models so that they can be used from mobile apps or through audio-enabled devices like Alexa, Echo, and others. And we'll have to build user interfaces for collecting audio samples and incorporating user refinements so that the model can continue to improve. So this is a case where we're creating an entire product based on data science. The next example is a case where imagine an industry like liquid bulk storage industry, where they have huge tanks which store liquids, and they need to maintain the liquid within a certain temperature range so that the liquid quality is maintained before it's distributed out further. Now, an industry or terminal like this would have a SCADA system to monitor the sensors and electrical equipment and activities in the terminal. And the SCADA system gives insights into the operations of the terminal. But as part of the overall digitalization, let's look at how data science can add some benefits here. So by looking at the sensors which give level of the liquid in the tanks, we can convert it to volume during our data preparation. And then we can build ML models to predict when a particular tank would require heating, or when a tank's heating will stop. So these predictive models, we are yet to see how to derive business benefit or ROI from them. So these models are typically fed into an online activity recommender or a daily planner, which can help us set out what the various activities at the terminals should be in such a way that the peak power demand at the terminal is kind of smoothed out so that our peak demand during a day is reduced. By reducing the peak power demand, we actually reduce the utility bill, and that's where we get the business ROI. So this is an example where we are using data science as part of a bigger digitalization exercise, and the business ROI of a data science model is not immediately obvious, but it is this business ROI which validates the entire exercise. Let's look at a final example of a telematics solution. So a heavy equipment manufacturer might have deployed equipments out in the field, or also testing new equipments which are coming up, and they have collected telematics data from their equipments over several months or years, and they would have created analytics solutions. They would have BI reports for their own purposes. They would also have analytics-based interfaces for their customers so that the customers can monitor their own equipment. Now, in such a scenario, we can imagine that by looking at the various packets of data coming in, we can detect predictors for failure or fault by looking at patterns in the packets. Also, we can detect anomalies of that a certain condition in the equipment seems to be different than usual. Also, we can do a few other things like use clustering algorithms to determine which operating conditions or operators are more amenable to the equipment and others are causing more failures. And these kinds of data science models can lead to business improvement in the testing process. The testing protocols for the machines could be adjusted. We can also send out proactive checkup and preventive maintenance personnel to the field before a failure or a fault actually happens, and this leads to increased ROI for the business. As part of working on some of these problems, we've encountered a few common misperceptions. So, Vinith, you want to share some of those?
Yeah, thanks, Srinath. So, as Srinath said, when we interacted with different people, customers, we came across these common misperceptions, misunderstandings people have about data science. So, let's look at a few of these. So one common misperception we came across was that if you have the data, you can predict anything. So this is cannot be said to be true in general. Unless your data has inherent trends, your model will not be able to capture them and provide good insights or make good predictions, accurate predictions. So your data, if it is random, your model also will not be able to give any insights or accurate predictions. The second kind of misperception we came across was people saying, let's have a good predictive model in a week. So this is a thing that we hear very frequently. And what I would like to say here is that data science, as the name suggests, it's a science and it involves a lot of experimentation. So we looked at the data science process, the different steps in the data science process, capturing, data preparation, machine learning, and so on. So that was a very simplified picture of the data science process. But in reality, it will be an iterative process where after the machine learning step, if you don't get good outcome, you may go back to the data preparation layer, pick some other variables, change them in a different way, and then use a different kind of machine learning model and see if you get good results. If not, then you may again go back to the data capturing stage where you capture some other variables, repeat the whole process till you get it right. So it is an iterative process. It may yield great results. But great results may take time. The third misperception is data science is easy. People tend to say this because they think a lot of libraries are available out there in the market. So you just can pick a library, give it the data, and it will give you a model. So even though that is true, you can do that, but it is very unlikely that that kind of approach will yield good results, because even though a lot of libraries are available, you need to first understand the data well. You need to understand the domain. You need to understand from the domain knowledge what variables might be useful for building models, which are the right kind of models you should be using, which are the best libraries for that, and so on. So getting a good model, getting it right at the end involves a lot of expertise. which is much more than just calling the data science libraries. The fourth misperception is this is common among the data scientists and even those who don't know about it but just have heard. So they think they see neural networks solving all kind of problems across the world, which the world is talking about. So they think that just give everything to the neural network and it can figure out. But this is not true. Very often simpler models do an equally good job as neural networks. Let's take the example of the scenario we saw where you have the salary data and the experience level data. You can either use a neural network to predict the salaries for unknown employees, or you can use a simple linear regression equation, salary equal to 2 into experience, the model that we saw in at the beginning of this webinar. So both might give you equally accurate predictions, but the linear regression, the simpler approach, that has its benefits like explainability. So what this means is, even though both models give you accurate predictions, but the linear regression also gives you an insight. It is telling you that salary is generally twice the number of years of experience, which means you now know that for every year in experience, the salary roughly increases by 2. This kind of an insight is not available from neural networks, which contains a lot of neurons connected to each other and they interacting and finally giving us the predicted outcome. But you hardly get any insights about the data and the relationships. Now, where is data science headed towards? So with IoT coming onto the scene and social media and many other channels through which data is coming, there is a data explosion, and it opens up the data science space for a host of interesting problems. For example, forecasting future values of sensors based on past sensor data, detecting anomalous signals based on past data through which you could know that there is a likelihood of fault in a device. You as manufacturers can sell machines or devices to customers which can capture the usage data of how they are being used and send it to you as the manufacturer, and you can then analyze that data to understand how your products are being used and so on. And then related to fraud, and the final one is related to predictive maintenance, predicting failures based on past data. So based on past data available to you, you can predict when any device or machine is likely to fail. And you could use this for your business in two ways. You could either in advance identify when a device will fail so that you can schedule a maintenance before it actually fails. So that saves you some cost. The other benefit could be if you are a manufacturer and you are able to predict the failure of the machines you have sold to your customers, then you can anticipate when those machines will fail, and that is the time when you're likely to get orders for new machines or devices from the customers. So based on those anticipated orders, you can plan your production. Now finally, the takeaways that we would want to focus on at the end is how you can use data science for your scenario, your business. So our recommendation would be that you should first identify a domain expert who understands your domain well, understands the data. Then that domain expert can collaborate with a team of data science experts or data scientists, and the domain expert can share his knowledge of the domain with the data scientists. The data science team can then decide what is the relevant data and capture the relevant data and which is in a good quality. The fourth step is an important one. So what we are trying to suggest here is that instead of having a full-blown data science project from the start, you can have a small discovery phase, because as we said, data science is an experimentation-based thing. So the kind of benefits, concrete benefits are not known at the start. So it is a good idea to just create some basic POC minimal models and see whether you are getting some promising insights or predict some accurate predictions, and what is the benefit of those to your business. And once you are convinced, then only should you go to the final step of executing a full-fledged data science project and putting all the team in place and executing the whole entire project. That gives you the best kind of predictions or insights possible.
Great. Thank you, Vinit and Srinath, for helping us understand what data science is all about and how it can, be a game changer for your today's business. And fortunately, we are able to cover this webinar in the exact time, 45 minutes. But I would like to extend it a little bit, and I would like to take up a couple of questions that are very interesting, and I would like to understand your views and thoughts on those. And the first question that we have here is a couple of attendees have already asked this question, and I'll just sum it up the questions for you. The first question is, we hear about Amazon and other AI kind of services which are available in the market. Where does it fit in? I mean, you showed us the whole complete picture on AI, data science, machine learning, and deep learning, and where should someone use such kind of AI services?
Yeah, sure. So we've seen quite a few AI services come up, especially you mentioned Amazon. So in the last year, they've come up with 3 or 4 new services oriented towards this. And you might also see some of these mentioned in our slide on the data science tools. Most of these services are interesting, and many of them are cloud-based services. And I think if you're trying to do a quick POC, or if you already have an established product to which you are evaluating if whether you can add a new feature like recommendation system-based features, then these libraries are probably good to try out. And as always, I would suggest that you rely on the advice of a data science expert who can weigh all the trade-offs such as vendor lock-in versus flexibility and other factors. One very special caution on this kinds of services is to take a look at their service agreements. A lot of these cloud services, they require data to perform well, and if you agree to them that they can use your data and keep it with them, you will often get a better SLA than if you say that you don't want your data to be kept by them. So if you have any sensitive data or healthcare data, those kinds of facts could be something to worry about. I think
and to talk about where it fits in the overall picture, so I would say we looked at the data science process, and these services are basically somebody has already performed all those steps and created all the final models with their pre-trained data and exposed them as services which you can call. But as Srinath mentioned, they may work for the data they have, and if your data is very different, your domain is very different, it may not work for your domain. So it may work for some common things like sentiment analysis. Amazon has services which can identify whether sentiment of something that has been said is positive, negative. So those kind of common examples could be solved using those. But if you have a very specific kind of requirement, these may not be useful for you.
Okay, that clears a lot of questions about those. Another interesting question is, and I think you also covered this in your whole webinar, that you also need a domain expert to help you understand the domain as well. So overall, what kind of a team is needed if you want to set up a data science kind of solution for yourself?
Okay, so as we discussed, there are these steps in the data science process. Each step generally has an expert who understands the techniques and libraries for that step. So overall, I would say you can have a chief data scientist who designs the overall data science process, and then you can have under the chief data scientist a domain modeler who understands the domain, captures the data, then a feature engineering expert who extracts the relevant features, then an ML expert who builds the model, and an inference expert who deploys the models for predictions in the end system, and finally a data engineer who takes care of the data storage and efficient ways to transport data and so on. So there would be these few people working under the chief data scientist, and based on the size of the project, you can have one people performing one or more of these roles. So hope that gives some idea about what kind of people could be involved in a data science project.
Okay. And I have one more question, and this is my personal favorite. With data explosion, as you said, IoT, social media, and stuff like that, do you see data science as a boon or a pain? I mean, you can talk in terms of the opportunities it's going to create, but at the same time, I believe it's going to be a part of automation as well. AI would be a part of it. So would it hamper this employment opportunities or anything?
So I think from my perspective, I see it definitely as boon. I would also want to see what Srinath believes in. So this is something that all people debate, and my opinion is that data science is definitely a boon. Great things can be achieved, but you need to be aware of the misperceptions that we saw. It is a thing that requires time and investment because it involves experimentation and often a lot of patience before you can get the right model. But if those things are taken care of, great results are possible. So overall, I see it as a boon, and I see it working together with human beings to explore new possibilities and reach new states. That's what my opinion is.
Yeah, I think I would agree. So just like any new technologies which facilitate new kinds of automation, these questions are bound to be there, and used in the right manner, I think it will turn out to be a boon. One of the general trends we are beginning to see is often people are trying to, because of all the hype around it, people are trying to use data science for areas where data science is not necessarily required. So that is something to be cautious about. But overall, I think it's a good trend.
Okay, great. So I think we are almost 7-8 minutes past our due time. So, but we have still a lot of questions coming in, but what we would like to do is, we will have Srinath and Vineet answer all these questions individually, and we will send out all the questions and answers to those to everybody in the coming week, and they can have answers to all their questions, and they can see also the questions asked by other members as well. And with that, I would like to wrap up this webinar. But before we go, I would like to inform you that we are coming up with 2 new webinars shortly. One is going to be a more detailed version of this webinar where we will deep dive into what machine learning is all about. And another is an exciting webinar on escalating cloud cost and how to control it. So both of these webinars will be coming up shortly. We will inform you and invite you for those webinars for sure. And we also had completed one webinar recently, which was demystifying industrial IoT. So we had again demystified what is industrial IoT, what are the myths around it, and how it can be used for your business applications and stuff like that. So you can watch that webinar whenever you want on our website. You can also click through the link on, you can download the presentation and click through the link. And don't forget to rate this webinar. You will get a questionnaire at the end of this webinar once the webinar is closed. And I like you to follow us on our handles so that you get a continuous source of interesting technological tidbits through our social media handles. Okay, thank you. That's a wrap from our side. Thank you.